Hi, in this video we're going to use something called the discriminant to distinguish between different quadratic graphs like this. Now let's remind ourselves what the discriminant does. If we had a quadratic equation like this, so we had ax squared plus bx plus c is equal to 0, we would use the quadratic formula to solve that, wouldn't we? And the important thing is the thing under the square root, this b squared minus 4ac, because if you were square rooting, say, a negative number, if b squared minus 4ac was negative, you can't square root a negative number, usually, and so therefore x would have no solutions, right? So if this discriminant, b squared minus 4ac, is less than 0, you have no real roots. Now, if we're thinking about a quadratic graph, so we had something like this, and we had a graph like that, and this was y is equal to some quadratic, ax squared plus bx plus c. Remember, the roots are where the graph intercepts the x-axis, so where the y value is 0. So if this y value was 0, so you had ax squared plus bx plus c equals 0, that would allow you to find out where the graph hits the x-axis, where y is 0. But you can see this graph is never, the y value is never 0 because it never hits the x-axis. So it's not possible for ax squared plus bx plus c to give you a y value of 0. And that would be because you have no real root. So that would be when b squared minus 4ac is less than 0. So in this particular case, the discriminant b squared minus 4ac would be less than 0 because there's no solutions when the y value here would be 0. What about the other cases? So if you had a graph like this, say, we can see that the y value is 0 at two distinct points, two different values of x. So we find those red points here by making y 0. So we'd make the y 0 here, ax squared plus bx plus c is equal to 0. And we can see there's two distinct solutions. So we look at this little table up here, where we have two distinct roots, two distinct x-intercepts, the discriminant is greater than 0. So let's write that. The discriminant is greater than 0. And then the final case is where we have one distinct solution, or equal roots as we call it. So in this particular case, if it touches like this, we have just one distinct solution, and we can see where we have equal roots, the discriminant is equal to 0. So that's when we have one distinct solution, also known as as equal roots, sorry. So b squared minus 4ac is equal to 0. So those are the three cases that we have. Now let's look at this question here. We need to calculate the discriminant. So if we rewrite this, let's give ourselves some space down here. So we got y is equal to, let's put the x squared term first, so minus 3x squared plus 5x plus 1. So it's in the form ax squared plus bx plus c. Let's work out discriminant. Well, the a is a coefficient of the x squared, b is a coefficient of the x, and c is a constant term. And then we're going to work out the discriminant, b squared minus 4ac, which is equal to 5 squared minus 4 times minus 3 times by 1. That's 25 plus 12, which is 37. But as that value there, we can see is greater than 0. So let's look at our discriminants. If b squared minus 4ac was greater than 0, which is this case here, then we can see we're going to have two distinct roots, two distinct x-intercepts. So which one is that? Well, this has two distinct roots. This has two distinct roots. That only has one. That only has one. So we know it's not these two. But can you see that this is a negative quadratic? It has a negative number in front of the x squared. And that gives you a sort of frowny face shape rather than a smiley face shape. So it's going to be a smiley face shape. So it's not that one because that one is upside down. That's a frowny face. So it is this one. The answer is figure 3. What about the other one? So again, let's work out the discriminant. We got 9x squared plus 6x plus 1. So let's do that down here. We've got y equals 9x squared plus 6x plus 1. In this case, the a is 9, the b is 6, the c is 1. And we're going to do b squared minus 4ac, which is equal to 6 squared minus 4 times a, which is 9, times by c, which is 1. And that actually gives you 0. Now, we saw earlier that if b squared minus 4ac was equal to 0, let's see the graph form. It's this case here, where b squared minus 4ac equals 0. You get one distinct root, equal roots, we say. So it's going to be either this one, or no, that's the only one. This is the only graph where we have one intercept with the x-axis. So the answer must be figure 2. So in the boxes, the discriminant was 0, and therefore this corresponds with figure number 2. And that is the final answer.